Hello, ladies and gentlemen. My name is Pranto, and today I'm going to demonstrate an open source Python package to run ETL pipelines. We have initiated this package during an academic course named Advanced Method of Data Engineering under a master's degree at Friedrich Alexander Universität, Erlangen-Nuremberg. So during this course, many students have conducted some very interesting data science projects, and we have realized that the ETL pipeline for any data science projects have some common task or some basic tasks to perform, and it will be very beneficial for the data science community if we can write those codes for ETL pipelines in a modular and reusable manners. Um, so with that motivation, we have started this package, and now I'm going to demonstrate how to integrate this package to your own project and use this effectively. So, as the name suggests, an ETL pipeline simply extract a dataset from a source, performs a bunch of transformation on the dataset, and eventually loads the dataset in a database or a data lake. For the demonstration purposes, I will be creating an ETL pipeline that extracts dataset from this kaggle source. To be very specific, it's a kaggle archive source, and will perform some transformation, some basic transformation on the dataset, and finally load the dataset in project.sqlite database under songs table. So first of all, let us have a look what this source contains. So this is the Kaggle archive. If I download this dataset, I will be downloading a zip file, and inside the zip file, there will be a CSV file named labeled lyrics cleaned CSV. And the CSV file has 5 columns, a column named hash, then artist, sec, songs, and label. These are the minimum knowledge we need to have to create the pipeline. Now let's get back to the documentation. So the first step to integrate the package in your project is to install the package, and to do so, you have to run pip install etl-pipeline-runner. So I have already created a virtual env, and I have already installed the package in my virtual env. And then the next step, as per the documentation of version 1.1.0, is to importing the necessary services to create the pipeline. So I'll be doing that. The second step is to writing your transformation that you want to perform on the dataset. So this is a function we have to write. The these are two basic transformation. We want to drop the first column of the dataset, and we want to rename the sec column as lyrics. So we want to drop this first column, and we want to rename this sec column as lyrics. Then the third step is to create the SQLite loader. So the definition of the SQLite loader says that the database name will be project.sqlite, and the table name where we want to store the data is song. And if the table already exists, then simply replace the table, and the output directory of this database is the data directory. The next step is to creating uh, a CSV handler. So we have seen in the data source that the archive contains a CSV file, and we need a CSV handler to handle that CSV file. Sorry. Yeah. So the definition of the CSV handler says that the handler will be handling the labeled lyrics cleaned.csv file, and the file CSV file is comma separated file. I have seen opened this CSV file before, so I know it is a comma separated file. And the transformation we want to perform on this CSV file is the transformation we have written before. Now, the name of the file here must be exactly same as the file name here. Now, the fifth step is to creating the data extractor. So the definition says that we will be extracting data from this source, and the type of the extractor is kaggle archive. And once we extract data from this source, we will be expecting at least one CSV file. And to handle that CSV file, we have defined a CSV handler. Now, there might be cases that one archive contains multiple files. For example, a CSV file, a Excel file, or a TXT file. So we can create several handlers and add those handlers here as a comma separated file handlers to handle the files. And then the sixth step is to creating the ETL pipeline itself. So the name of the pipeline is songs pipeline, and we just need to say which extractor this pipeline will use. And the final step is to running the pipeline using a ETL queue. Now, if you want to run the pipeline without the queue, you can also run the pipeline individually with a by calling the run function. But we encourage you to use the ETL queue. We have introduced the concept of ETL queue because we have seen in some cases or in some projects that the engineer or the developer wants to run the pipeline in a sequential manner. That means the sequence matters to them. That also means that one pipeline is dependent on another pipeline, so the sequence really matters. Now, the final thing I would like to explain is, since we are extracting data from Kaggle, we need some credential to communicate with Kaggle API. And there is a section in the documentation of explaining how to get your own credential from Kaggle. So if you go to this link and scroll down to the API section and create new API token, this will download a kaggle.json file with your username and key. So if I go to this link and if I click create new token, then I will be downloading exactly this kaggle.json file. You just have to put this kaggle.json file in your root directory. Now, if I run this pipeline, python pipeline.py, I will be running the pipeline. So it is now extracting the data from the source and then performing the transformation and finally loading the data in the database. So now I have project.sqlite database in my data directory. If I open this database, I have the songs table, and I have 4 columns. I do not have the hash column here. I have artist column. Sec column is renamed to lyrics, and the rest are as it is. So as expected. This was an example about how to integrate this package to your project, but this example was very specific to Kaggle type of data sources. However, you can use this package to extract data from a source that directly returns a CSV file. So, as a version 1.0 I'm sorry, 1.1.0, the package can extract data from Kaggle. It can also extract data from a source that provides CSV files. It can perform transformation flexibly, and it can run pipelines in a queue. We have some ideas for future features. The first idea is to uh, have the capability to extract data from other type of sources than Kaggle and CSV, maybe from a Google Drive or from directly from a database. And another idea is to handle Excel and .txt files. Currently, this package can only handle .csv files. Another possible feature could be loading to other type of databases than SQLite. Uh, we it would be very interesting for the package to load the data to a PSQL database, for example, or to a MongoDB. And the most my favorite one is executing the pipeline concurrently. So currently we can execute a data pipeline individually, or we can also execute the pipeline in a queue. But in some cases we might want to execute multiple pipelines concurrently in a parallel manner. So these are also some interesting future features. If you like any of these ideas, or you have your own idea, please feel free to create a new issue, and feel free to create a new pull request as well, since this package is an open source package built in order to help the data science community. And this presentation ends here. Thank you very much for being with me and listening to the presentation. If you like the repository and the work, please give a star to this repository. And thank you so much.